solve the following Bernoulli's differential equation. So this equation is Bernoulli's. In fact, the standard equation would have been like dy over dx plus function of independent variable y equals, let's say, qx. This is linear. Okay, y prime and function of x, just the function of independent variable, times y to the some power. So when we have this form, this is Bernoulli's. Okay, it's non-linear, but with certain substitution we can make it linear, and after we have a linear we can find an integrating factor and solve. But this one is not exactly in this form. This one is already simplified. If we divide through by y squared, which is not needed, but let me show you, dy over dx divided by y squared, right? So this is y 1 over y squared. Now this is in that form. Dy over dx, y px is 1, and qx, that's 1 as well. Yn is y to the negative 2. Okay, this one was is in Bernoulli's form, but somehow this is written in this way. To solve Bernoulli's equation, what we have to do is we divide both sides by y to the n here, and that's already done here. And then after we divide, we want to convert. Somehow our goal is to convert as a linear, and then the variable will, let's say, v. We'll have v dv over dx and some function of, I don't know, some function of x. We can have some function of x there, then we divide, and right hand side another function of x. So we want to keep in this linear form. So we let the y part, y to the power, whatever power, that is v. Okay, that's the assumption. So let v be this one whole thing, y cubed. So this becomes v. Now we want to convert dy over dx in terms of v. So to find dy over dx, let's differentiate both sides with respect to x. So then dv over dx, let's find the derivative of y cubed with respect to x. So this would be then from chain rule 3y squared times dy over dx. And we wanted dy over dx, so dy over dx divided by 3y squared. So 1 over 3y squared dv over dx is equal to dy over dx. Now we have all the substitutions. Let's convert this Bernoulli's equation into a linear one. Okay, with this, then y squared, I don't know anything, I just write y squared for now, times dy over dx is here, 1 over 3y squared dv over dx, plus y cubed is v, equals 1. Now let's simplify y squared cancel, 1/3 we can multiply through by 3, so that 1/3 is gone. Okay, so this one is 1/3 times 3 is just 1, so dv over dx plus 3v equals 3. Okay, now this is linear in v with respect to x. Okay, this is linear in variable v with respect to x. And as soon as we have linear ODE, we find an integrating factor. Integrating factor mu is e raised to integral of this function, which is only 3 in this case, 3 dx, which is e raised to antiderivative of 3 is just 3x. Now when we multiply both sides of this in this linear differential equation, Okay, we multiply, then this transforms into derivative of dependent variable v times integrating factor equals 3 times, we're going to multiply both sides, right? Left hand side is automatically this and right hand side is 3 e raised to 3x. Okay, if you are not getting this step, then you have to review linear ODEs first. Now we integrate both sides. V times e raised to 3x equals integral of e3x with respect to x. Now we can integrate this, which is 3 outside. Antiderivative of the e3x is e raised to 3x over 3 plus c. Okay, we can cancel 3 here. So v times e raised to 3x equals this. Now divide both sides by e raised to 3x. So v equals, oh, we had only e raised to 3x. Now we are dividing by this. So 1 plus c over e raised to 3x. But v was not in the question. What is v? v was y cubed. Now we back substitute. So y is v is y cubed. Y cubed equals 1 plus c over e raised to 3x. That's the final answer. In this case, we can solve for y. If we take cube root of both sides, y equals cube root of this junk, 1 plus c over e raised to 3x. Final